Right, in this video we'll look at the conservation of momentum. So what do we mean by the conservation of momentum? So in a collision or an explosion, the total momentum before the event, before the collision or the explosion, will equal the total momentum afterwards. So the momentum is conserved. We can't lose momentum, okay? So let's get this down. So in a collision or an explosion, okay, so in a collision or an explosion, the total momentum before is equal to the total momentum afterwards. So let's take this example here then. So if we've got these two little carts on an air track, okay, so it's essentially a frictionless surface. If this car on the left is moving at 10 meters per second and it collides and sticks to the car on the right, then what velocity are they going to move away with? Well, because the mass has essentially doubled, because one car has become two cars, then because the mass has doubled, the velocity has to halve. Remember, momentum, P, is equal to mass times velocity. If you double the mass, you halve the velocity. Yeah. So this car here will collide with this car, and they'll both move off together with a new velocity of 5 meters per second. Yeah. Okay, let's look at a slightly different example. Now, I've got a cannon here. Okay, so the cannonball initially the cannon and the cannonball are stationary. Okay, so they're stationary. So the combined momentum, the total momentum before, if they're stationary, is going to be 0 kilogram meters per second. Okay, so the ball and the cannon are not moving, so it's got total momentum before of 0 kilogram meters per second. Well, afterwards, the cannonball is fired at a velocity of 10 meters per second. Okay, so the cannonball is fired at a velocity of 10 meters per second. Well, the cannon is going to move backwards in the opposite direction because the momentum has to be conserved. Okay, if the total momentum before this explosion is 0, then the total momentum after has to also equal 0. So let's have a look at how we can calculate the recoil velocity of the cannon. Firstly, we can work out the velocity, the total momentum of just the ball on its own. Okay, so the momentum of the ball on its own is just going to be 5 kilograms times by 10 meters per second, mass times velocity, and we get an answer of 50 kilogram meters per second. Okay, so 50 kilogram meters per second. So if the ball has got a momentum of 50 kilogram meters per second, what must the momentum of the cannon be in order to make the total momentum 0? So if the ball has got 50, then in order for the total momentum to be 0, the cannon is therefore going to have a momentum of minus 50 kilogram meters per second. Yeah, because 50 plus minus 50 is 0, so that will satisfy our equation. Now, what do we mean by minus 50 kilogram meters per second? So it's a vector. Yeah, momentum is also a vector. That negative sign just means that it's moving in the opposite direction. Yeah, so that negative sign is a vector quantity. It's got a magnitude and a direction, with the direction indicated by the negative sign. So the cannon will move backwards. Yeah, that makes sense, doesn't it? So therefore then, what's the velocity going to be? So if you want to rearrange the equation P equals mv to get to v, which is what we're trying to calculate here, we just take the momentum and divide it by the mass. Okay, so momentum divided by the mass is going to equal velocity. So we've got the momentum, which is minus 50, yeah, because it has to total 0. So minus 50 is divided by the mass, which is 100. You get minus 0.5 meters per second. So in this case, the ball is going to move to the right at a velocity of 10 meters per second, and the cannon is going to recoil at a velocity of negative 0.5 meters per second. Okay. Right, that was a slightly complicated example. Okay, but I'll just quickly run through what I did to get here. So before, we've got a total momentum of 0 kilogram meters per second. Remember, it's stationary. If it's stationary, it's going to have no momentum. So the total momentum before is 0. Now, after the collision, because of this law of momentum, we have to keep it has to be the same as it was before. So if it was 0 before, its total momentum is 0 afterwards as well. Okay, so momentum before is 0, momentum after is also 0. Yeah, we can work out the momentum of the ball just by taking the mass and timesing it by the velocity. We get 50 kilogram meters per second. Now the momentum of the ball plus the momentum of the cannon, the combined momentum, has to equal 0. Therefore, the cannon is going to have a momentum of a negative 50. Yeah, we can then take that momentum and divide it by the mass, and we get a velocity of negative 0.5 meters per second. It's moving backwards, negative, at minus 0.5 meters per second. Okay. Right, so have a go at this example then. Now, I would give you some advice here. So my approach to this question will be to work out the total momentum before the collision first, and then make it equal to the total momentum after, and then you can just divide that by the mass to get the velocity. So have a go at that. Unpause the video, and I will walk through the solution. Right, so let's start by finding the momentum of the bullet. Okay, so the momentum of the bullet is 10 grams times by 200. Okay. Now it's 10 grams times by 200, so we're going to get 2,000 gram meters per second. Okay. Now the momentum of the block is going to be 0 because it's not moving at all. So 0 gram meters per second. So the total combined momentum before is 2,000. What's the total momentum after this impact? Well, remember, momentum before is momentum after, so it's going to be 2,000 again. Okay, so 2,000, and then we've got to divide that by the total mass, okay, because the block and the bullet are now embedded together. So the combined mass is just going to be 500 grams from the block. Add the 10 grams of the bullet, because they're now one thing, essentially. Okay, so 2,000 divided by 510 will give you an answer of approximately 3.9 meters per second. Okay, so in other words, the bullet will strike the block, and then the block will move away after the impact at 3.9 meters per second. Okay, I will see you in the next video.